Now we're going to learn how to factor trinomials that are non-monic. In other words, the lead coefficient is not equal to 1. Now as a warm-up, I'd like you to multiply these binomials together and write the result in standard form. Pause the video, do your work, and then I'll show you the answers. Okay, here are the answers. Now the reason I had you do that is for the same reason that when we started learning about factoring in the first video, we looked at multiplication first and then what the reverse of the process was. So now let's take a look at factoring polynomials that are not monic. In other words, polynomials where the lead coefficient is not equal to 1. So first, as we did just a moment ago, we're going to look at the multiplication process and then see how to reverse it. So if we multiply these two, we can set up the expansion boxes. Look like this. Fill in the center. And our result is 6x squared plus 23x plus 20. Now let's look at it in reverse. We know that the upper left and lower right squares in the expansion box have to have the x squared and constant terms, respectively. But the trick is, how do we fill in those two other boxes with the 8 and the 15 that will allow us to fill in the blanks and come up with the factors 2x plus 5 times 3x plus 4. We're going to look at one more. When we multiply these together, we get 8x squared plus 22x minus 21. If we were factoring, we would be given 8x squared plus 22x minus 21. We would know that the 8x squared and the negative 21 go in these positions in the expansion boxes, but we'd have to figure out a way to fill in those two remaining boxes so that they add up to 22x, and that when we multiply the binomials, we will get 8x squared plus 22x minus 21. Now, let's look at where the coefficients come from. The coefficient of x, 23, is a result of adding 15 plus 8. And we note that 15 comes from the numbers 3x times 5, 3 times 5. And the number 8 comes from 2x times 4, 2 times 4. So we see that the 23 comes from adding 15 and 8. But when we multiply 15 times 8, note that we don't get 20, we get 120. Note that that is 5 times 3 times 4 times 2 for 120. And we also note that if we take the coefficient of x squared and the constant term, 6 times 20, that also gives us 120. So there's our clue as to how to find these numbers. Let's look at one more problem. 8x squared plus 22x minus 21. We need two numbers that add to 22 and multiply to 8 times negative 21, that's the coefficient of x squared, times the constant term. Again, they multiply to 168. And we find that those two numbers are negative 6 and 28. So, now let's go through the whole process of factoring 8x squared plus 22x minus 21. So we put the 8x squared and the negative 21 in their proper place in the expansion boxes. And then we find that we need two numbers that add to 22 and that multiply to 8 times negative 21. And as we just saw, those two numbers would be negative 6 and 28. And now let's see how to fill in the outside of the expansion boxes so that we can get the two factors. Now we look at the first column and we note that the greatest common factor of those two terms is 4x. So we'll put 4x above that column. Next, we'll look at the first row. And we'll notice that 8x squared and negative 6x have a common factor of 2x. Next, we'll fill in the column and the row that are missing in the same way. We can look at the column and note that the greatest common factor is negative 3, and look at the row and see that the greatest common factor is 7. And now we have the two factors, 4x minus 3 across the top times 2x plus 7. So if asked to factor 8x squared plus 22x minus 21, you can use the expansion boxes this way to come up with the factors 4x minus 3 times 2x plus 7. Let's look at one more example. 5x squared plus 17x minus 12. We put the 5x squared minus 12 in their places in the expansion boxes. And then we see that we need two numbers that will add up to 17 and will multiply to 5x minus 12, or negative 60. And those two numbers would be negative 3x and 20. We can see that the greatest common factor for the first column is 5x. Then for the first row is simply x. And then the right-hand column would be negative 3 as the common factor, and then the bottom row, the common factor would be 4. Now we have the two factors, 5x minus 3 and x plus 4. So if you were asked to factor 5x squared plus 17x minus 12, your answer would be 5x minus 3 times x plus 4. Now you might ask, what happens if we split the table the other way? Remember that when we first broke this up, we had the 20x and the negative 3x in different positions. If we follow the process, finding the common factors of each row and column, we'll see that we get exactly the same factors, 5x minus 3 times x plus 4. I'm going to leave this one for you to try. Pause the video, give it a try, and see if you can figure it out. Okay, here's the solution. First, we know that 3x squared and 2 go in those positions, and that we need two numbers that add to 5 and multiply to 6. If you got stuck here, let's stop the video and see if you can complete this from here. All right, we'll continue. The two numbers that add to 5 and multiply to 6 are 3 and 2. So we put those in those places. And then we find the common factor for the first column, which is x. Common factor for the first row, which is 3x. Right-hand column is simply 1. And the bottom row is 2. So that we see that our factors are 3x plus 2 times x plus 1. Here's some others for you to try. Remember that you need to first find two numbers that multiply to the product of the x squared coefficient and the constant term, and that add to the coefficient of x. Fill in the expansion boxes, and then remember to write your answer in factored form. Stop the video now, try these three examples, and then restart the video to find your solutions. Okay, here are the solutions. Here are three more for you to try. Take a look at them, give them a shot, stop the video, and then restart the video to find the answers. Okay, here are your solutions. And this ends our video. I made another short video, part 3a, that shows you how to do this type of factoring without the expansion boxes, that is, doing this factoring algebraically. If you'd like to learn that, check out video 3a.